Hello everyone, I'm Anandian. Today we'll be discussing about Dijkstra's algorithm. It is also known as shortest path finding algorithm. Firstly, introduction to Dijkstra's algorithm. It was developed by Edgar W. Dijkstra's in 1956. He found this to find the shortest path between nodes in weighted graphs. It is widely used in networks, maps, AI, and routine systems. Key concepts of graph representation: nodes and edges. Graphs have nodes or vertices connected by edges. Weighted edges. Edges carry weights representing cost or distances. Data structures. It uses adjacency matrix or list to store graphs. Now, an example for this graph representation is city as nodes and roads as weighted edges. Now we move on to algorithm initialization. Firstly, we mark all nodes as unvisited, and we set the distance to all nodes as infinity, except the source node, which we set as 0. Set the source node as current, and while there are unvisited nodes, for the current node, consider all its unvisited neighbors. Calculate the tentative distance to each neighbor. We can calculate the tentative distance by current distance plus edge weight. If the tentative distance is less than the currently known distance, update the distance. After checking all neighbors, mark the current node as visited. Now, visited nodes will not be checked again. Now we move on to the select. Select the unvisit node with the smallest tentative distance as the new current node. Now we repeat until all nodes have been visited. The shortest path from the source to every node is known by calculating everything after the visiting of all the nodes from the source node. Example. Now I'll explain step by step demonstration. To start at a node. Initialize distances and start from the source node. Update neighbors. Calculate tentative distance for adjacent nodes. Select nodes, next node. Choose next closest node and repeat updates. Find shortest path, trace path once all nodes are visited. Now we move on to applications and use cases. Use in network routing, GPS navigation, AI pathfinding, and resource allocation. In network routing, optimized data paths is in communication networks. In GPS navigation, we calculate the shortest driving direction worldwide. In AI pathfinding, guides the robots and robot and game characters efficiently. In resource allocation, optimizes delivery and logistic routes. Now we end up at the conclusion of the video. So, in the conclusion, it is an efficient path finding. Dijkstra's algorithm finds shortest path efficiently. It is widely applicable, used in many real-world routing and AI tasks. Limitation: does not work with negative edge weights. It does not work with either. Does not work with negative edge values or the weights between the two edges.